Okay, so the first one up here, 3y equals 5x minus 6. What do I have to do that? Yeah, we got to get y by itself. Right now we have the 3 there, which multiplies it. So to get rid of it, we have to divide. And when we divide an equation, we have to divide every piece. So the 3 divides out, we're left with y. 5x divided by 3, well, that's just 5 over 3 x. Negative 6 divided by 3, negative 2. Does everybody understand why I called that a negative 6? Because it's minus 6. Yep. So now, where do we start? On our graph, we're going to start at negative 2 right there. And from there, we're going to go up 1, 2, 3, 4, 5, and over 1, 2, 3. There's my line. How about the second one here? What do we have to do? Yeah, y has got the plus 5, so we're going to get rid of it by subtracting 5. Now, when we add or subtract to an equation, we only have to do it to one piece on each side. So now the 2x we can't subtract 5 from, but we can subtract 5 from the 4. 4 minus 5 is negative 1. So where do we start on the graph? Negative 1 right there. And then the 2 becomes a 2 over 1. We make it a fraction. So from this point we go up to over 1. Any questions? Try that one. So what do you do first? Add 2. So 5y equals 3x plus 3, and then divided by 5. So y equals 3x divided by 5 is 3/5 x. 3 divided by 5 is 3/5. So that means we're going to start down here, or up here, sorry, at positive 3/5. Yes, you can start at a fraction for your intercept. It's not pretty, but you can do it. Then you can go up 1, 2, 3, and run 1, 2, 3, 4, 5. Yes, none of the points are going to be on lattice points or good points, but it still works. How about this one? Do that one quick. Okay, first step here. To get y by itself, we're going to subtract the 2x. So we got negative 3y equals 6 minus 2x. And then divide by the negative 3. So y equals 6 divided by negative 3 is a negative 2. Negative 2x divided by negative 3 is a positive 2/3 x. So graphing that, where do we start? Negative 2 right there. And from there we go up to over 3. Any questions on those? You guys seem ready to do them on like maybe a quiz coming up in the second hour class?
No. 3 days in a row.
Well, technically 8:30 is a separate day.
Oh, okay.
Okay.
Who writes your calendar?
It's the second Friday of the week, yeah.
Well, we gotta make it for Monday then.
Well, this class always used to be scheduled 1 hour a day for 5 days, and now it's the 2 hours on Fridays, so it messes things up. Okay, so I want to explore the slope a little bit. I have a line that goes through my graph like that. To find the slope, I need to find a rise and a run. Generally easiest to do if I can find what's called lattice points or grid points. Here, where it crosses the axis, if it crosses at a integer numerical value, an integer point, then it's fairly easy. And in this case, the line does in both spots. So how much does it rise here? 3. How much does it run? 4. So it has a slope, and the abbreviation we use for slope is the letter M of 3 over 4. It rises 3, runs 4. What's that? M is just a letter that wasn't used for anything else. To be perfectly honest. It was available. Well, that's where the MX plus B format came from. But, yeah, M just wasn't used for anything else. So for this one, what's our rise here? 2. What's our run? 5. So the slope is 2/5. Good. Excuse me. So for this one, what's my rise? -3. Good. We go down 3. What's my run? 2. So the slope on that one is -3/2. Not so bad, right? Find the slope on all 3 of those quick. Okay, so for this one right here, what'd you get for a slope? -1, yeah, down 4 over 4. This one right here, what'd you get for the slope? 3 over 2. Up 3 over 2.
I wrote it right, read it wrong.
Okay. This one, what'd you get for a slope? Down 3 over 4, so -3/4. You guys comfortable with those?
Why was that one 3 over 2 when it's -2?
It's, this one here is up 3. It's not the point. This is at the point -2. You're correct, but it's not the location. It's the movement to get from one point to the next. You're always going from left to right. So you're going from this point to this point. And it's to get there from here to there, you go up 3 and then over 2. That's a very good point. It's not the location, it's the movement. Find the slope of that line. No, it's supposed to be lined up with that point there and that point there. So it does not cross the axis at a hash point. Well,
Hold on.
It goes up 3, run 6. So 3 over 6 or 1/2. Now let's look at this. This point right here is the point 1, 3, correct? Or negative 1, 3, correct? This point here is the point 5, 6, right? How could I have found the rise? Careful. The rise is the y coordinates from 3 to 6, rows 3. So to find the slope, we define it as y2 minus y1. If this is my second point, this is my first point. Y2 is the y coordinate of point 2, which is the 6. Y1 is the y coordinate of point 1, which is the 3. 6 minus 3 is 3. It's my rise. My run is then from negative 1 to 5, which is 6 units. So that's x2 minus x1. x2 then would be the 5, the x coordinate of point 2. x1 would be the negative 1, the x coordinate of point 1. 5 minus a negative 1 is 6. So if I give you that a line goes through the points 7, 3, and 5, negative 3, the slope is going to be, I'll call this point 1 and point 2. What's y2 going to be? Negative 3 minus 3. Y2 is the negative 3, y1 is the 3. So y2 minus y1 is negative 3 minus 3. x2 would be 5. That's the x coordinate of point 2. Minus 7 is the x coordinate of point 1. So now negative 3 minus 3 is negative 6. 5 minus 7 is negative 2. Negative 6 over negative 2 is 3. Slope of 3. Is that making sense? Find the slope of that line going through those 2 points. So, slope equals what goes on top. I call this 1 and 2. 0 minus 5. And on bottom, 8 minus negative 2. 0 minus 5 is negative 5. 8 minus a negative 2, 10. Negative 1/2. Any questions?
Negative 1 over 2, or is it negative 1?
Either one. It could be negative 1 over 2, negative 1/2, or 1 over negative 2. They're all negative 1/2. They all mean the same thing. Think about it. Negative 1 over 2 is meaning you go down 1 over 2. Right? Negative 1/2 means you go down 1/2 over 1. Same difference. 1 over negative 2 means you go up 1, back 2. Again, same difference. They all give you the same line. Same slope. Generally, we always make the run positive. So the negative goes, positive or negative usually goes with the rise. So the run is always left to right. Well, now it's time to take the next step. The next step can you tell me the equation of this line? Well, there's 2 pieces of information we need. One is the y-intercept. What's the y-intercept going to be here? Yeah, negative 2. Does everybody see where the negative 2 comes from? That's where it crosses this y-axis. Right here, negative 2. The slope is then we rise how much? 2. We run 3. Now this does go up from left to right. Again, this might be a negative 2, but to get from here to here, we're going up 2 and over 3. So it's a positive 2/3. So my equation is y equals slope times x. So 2/3 is my slope. So 2/3 times x. And then the y-intercept's a -2, so -2. So how would I find the equation of this line? First piece of information, what's my y-intercept? +3 right there. What's my slope? My rise is -3. My run is 1. So it's a -3 over 1, or just -3. So the equation is y equals -3x plus 3. Now which one?
Because you wrote -3 up just above the purple.
Here? No, that's down 3. That's a -3. -3x. That's +3. Find the equation of those two in your notes quick. Okay, so for the first one, what'd you get for an equation? 1/3 x plus 1? -1/3 x plus 1. Does that look better? Everybody get that? Anybody have any questions on where that came from? Second one, what do we get? Y equals 2/5 x plus 2. How many of you got that? Any questions? We're good? Okay, we got some for you guys to try. In the book, big book, of course, page 400, exercise 16-2. Page 401, exercise 16-3. And also on page 401, exercise 16-4. And page 404, exercise 16-7A. It is Friday the 13th. That's what got Dale, wasn't it?